Okay guys, today we're going to go over basic data types. You can look through this and get a pretty good idea of what they're trying to tell you. Everything has to be declared. Integer for your whole numbers without decimals. Takes only 4 bytes of information, which would be 32 bits of information. 32 individual zeros and ones to store a whole number. Well, whole numbers, I guess I should say. You have float, which stores fractional numbers containing 1 or more decimal, sufficient for storing 7 decimal digits. Why 7? Because it's 4 bytes of information, 32 bits, and we'll go over that math here in a second. It's actually best to start by explaining characters. So you have your double, which if you use nothing but double, that's pretty much your base, your best one, because a double can handle an integer, but an integer can't handle a double. Like in a mathematical equation, if you wanted to add 4 plus 2, you could declare the digits as doubles, and it wouldn't hurt anything. It would still return 6. But if you did 4.2 plus 5 or whatever, it would not come back 9.2 if it was declared as an integer. The 0.2 would be left off. It would just come back as a 9. So double's like your safest bet. It just takes more space. And notice that it can do 15 decimal digits. A Boolean is 1 byte, and it stores either a true or a false. It's not going to say true or false. It will say 0 or 1. 0 being false, 1 being true. You can see a lot of that in the registry. A lot of the register keys are Boolean values. It's either true or false. And actually, let me see if I can get into mine. I got a lot of things open. It might give me trouble. And then a CHAR, that's for character. And it is 1 byte, and it stores a single character. Now let's just kind of go down through anything and see. Yeah, here. I feel like Blender off Futurama when he had the bad dream about the 2. They must have changed some things, but it's usually all zeros and ones. Yeah, they really did change it, but it used to be nothing but zeros or ones, only true or false. So these would all be Boolean. These would be declared as Boolean characters. Okay, so a character has 1 byte. It stores a single character, letter, number, or ASCII value. Let's look over here. Here's our ASCII table. Notice you have your decimal numbers, which have symbols that go with them. Now, this should help you understand why it is so important to declare. You have to declare to the compiler that this binary code is supposed to be a decimal number. If not, it may come back with a symbol. And if we go so far up, we will start seeing, here's our ABCs, start at 65. So when you declare something as a CHAR, standing for character, here's the binary code that has been seen by the processor. But what does the processor do with it? Well, you did declare it as a character, so it will know to use this A, uppercase A, not put a 65 in that space. So that is the purpose behind declaring things. Now, another thing I wanted to point out was we noticed over here it is telling us 8 bytes for 15 digits. Well, here's the math behind that. 8 bytes, there are 8 bits in each byte, gives you a total of 64 bits. Okay, so each digit takes 8 bits. So you divide, yes, that's right. So you divide the 64 bits that you have by 8, and you are back to 8. So 8. Let me see, what else can I go through in here? The exercises. Let's go through the exercises together. My number equals 9. 9. What do you think that is? There's no decimal point, is there? Integer. My double number equals 8.99. Well, it's saying double, so they might want us to go with double. But 8.99, I'd have to say float would work too. But we'll try double, just because it says it right there. My letter equals A. Oh, we just went over that, didn't we? CHAR for character. Boolean is, I guess, typing out the whole thing. No, you don't. You don't type in the whole thing. It's just BOOL to declare something as Boolean. That's what I thought. My text equals hello world. What can we use for that? Fraction numbers, sufficient for storing 7 digits. Whole numbers without decimal, single character. We are missing one. Oh, string. There it is. Wonder why it's not in that chart. Let's look up above. No, I guess it doesn't matter. Let's see if we got that right. The only thing I don't know if we... Well, I'd have to say double is right because that's exactly what fit. So depending on what you want to do, what you want it to say, you want to choose the appropriate data type. It'll probably be a little bit... It'll probably be later in the course before we get into Booleans and true and false values. And try to think of like the original Oregon Trail if you ever played that. It'll say, do you want to turn left or right, Y or N? The true and false values are what's going to determine the outcome of your next decision or where you go. Or I mean, I know on the original Oregon Trail, most people I feel like they usually did not make it. So, but if we get to the point where we are programming little video games, Boolean will come in very handy. Well, that's all I have on there for data types, and this is more just an overview. We'll get more into using them later in the lessons. So try to have fun, and I'll probably just post the notes for you. I'm just going to copy it right out of here because that'll make a nice reference in the future. So, alright guys, try that. I'll put an exercise up for you, and good luck. Let me know if you have any questions.